Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 3-methylenesobenzofurane 1,3H, 1,3-methylenephthalide, which has a benzene ring fused to a 5-membered lactone ring bearing an iexomethylene, is equal to CH2 at C3 and a carbonyl at C1. Moving on to the next step. The iexomethylene of the lactone undergoes Friedel-Crafts alkylation with benzene. The UlCl3 activates the electrophilic alkylation at the methylene position, introducing a phenyl group. This gives compound a 3-benzylidenephthalide or 3-benzyl 3H isobenzofuranone derivative. More specifically, the methylene reacts with benzene via Friedel-Crafts to give 3-benzylphthalide or 3-benzylidinephthalide. Given the iexomethylene, electrophilic addition places pH at the iexo carbon, giving 3-benzylidinisobenzofuranone, a benzylidene phthalide, as compound A. Moving on to the next step. PCl5 converts the lactone carbonyl to a gemdichloro group, or acid chloride, converting C is equal to O of the lactone to CCl2, giving a dichloride. This opens or modifies the ring, the lactone CO bond, and C is equal to O are converted. PCl5 on a lactone typically gives an acid chloride with ring opening, producing an ortho-chlorocarbonyl benzyl chloride type intermediate, or it converts C is equal to O to CCl2. With a cyclic lactone phthalide, PCl5 gives the corresponding imidochloride or dichloro compound. Specifically, PCl5 converts the lactone to a gemdichloro intermediate, the ring opens to give an orthosubstituted benzene with CCl2 and CHPH, or is equal to CHPH, groups as an open-chain dichloride. And for the final step, reaction 2H2PD BaSO4, Rosenmund type, partial hydrogenation. This is a controlled partial reduction. The vinylic allylic CCl bonds can be selectively reduced to CH under Rosenmund conditions. PD BaSO4 is a poisoned catalyst for selective reduction. The gemdichloride CCl2 is reduced to CHCl or further to CH2, but under Rosenmund conditions 1Cl is removed. Alternatively, considering the structure, PCl5 converts C is equal to O to C, Cl is equal to and H to PD, BaSO4 reduces 1CCl. The net result of I plus 2 on the phthalide with benzylidene group gives compound B an orthodisubstituted benzene bearing an aldehyde, CHO, and CH is equal to CHPH or similar group. Actually, the combination converts the lactone to a dialdehyde. More precisely, PCl5 on lactone gives iminium chloride type, then H2PD BaSO4 gives a partial reduction to aldehyde. The net result is phthalaldehyde derivative, specifically 2,2-oxothiol benzaldehyde or orthophenylenedicarboxyldehyde bearing a pH group. Compound B is likely to formal cinnamaldehyde derivative or an ortho-PHCH is equal to CH benzaldehyde. Hydrazine reacts with two carbonyl groups, dialdehydes, to form a cyclic dihydrazone or a phthalazine. With an orthodialdehyde bearing a pH group, hydrazine would condense with both aldehyde groups to form a cyclic structure, phthalazine derivative. The two C is equal to O groups react with the two NH2 groups of hydrazine, H2N NH2, to form a 5-membered ring containing N is equal to N or CH is equal to NN is equal to CH fused to benzene. This gives a phthalazine type product with the pH substituent on one carbon, specifically 1-phenylphthalazine or 1-phenyl 1,2-dehydrophthalazine. The product of hydrazine with an orthodialdehyde, one being PHCH is equal to, the other being CHO on the ring, gives a cyclic hydrazone. The structure has the benzene ring with two adjacent positions bearing C, pH is equal to N and CH is equal to N connected through NN, hydrazine, forming a 5-membered dicyclic ring fused to benzene. This matches option B, orthodesubstituted benzene, where C, pH is equal to N and CH is equal to N are connected by NN bond, with pH on the C is equal to N carbon. Why other options fail? A, has H instead of pH on the C is equal to N carbon, incorrect, as pH comes from Friedel-Crafts step. C, has pH and OH on the ring carbon, does not match the reaction mechanism. D, is simply cinnamaldehyde styrene derivative, does not account for the ring-forming reaction with hydrazine. Therefore, the correct answer is B. Therefore, the correct answer is option B.